Well, this is second part of experiment 2, relative density determination. You see that the table in front of which Sony is standing has a vibration facility, right? Then you have that mold in which dry sample is already kept. Here also sample should be dry, and if required, you have to sieve it also. Those things you come to know in actual lab. But here, that dry sieved soil, it has already been filled. But before that, you have to take the empty weight of the mold, and diameter and height you have to take using the digital vernier caliper that is there in the lab. So you'll know the empty weight and volume, right? Pi over 4d square h in centimeter cube. So weight always in gram and volume always in centimeter cube. Then you have to loosely fill it. That soil will be in the tray initially. From tray, take a small cup, water content determining cup, and fill it loosely from the bottom. Your cup should always be 3 centimeter above the soil surface each time. You have to fill it from bottom till top, and when it is completely filled, then using that straight edge, that Shonizi will be showing, that's your straight edge. Thickness you can measure, you can level the surface, and combined weight you can take. So the difference gives you the your loose soil weight. So that weight over volume is your loose density, right? After that, you keep it on that vibrating table. There are 3 nut and bolts, so you'll be tightening it, and then you'll keep that circular disc on top of it. Using, if required, handle you can use. Its thickness also you can measure, right? Then on top of it, that heavy weight, it is 12 kilogram, that goes, right? So it goes there, and then you have this guiding vane. So proper protection while vibration, right? So here you see that the motor and it has a belt. So there is a switch. So it is properly clamping such that there is proper, firm connection, right? And then all those straight edge, all those keys, handle, everything will be removing, and then there is a switch, and that switch you have to rotate clockwise once, and let's say 5 minutes of vibration, then close, then again anti-clockwise, and again 5 minutes of vibration, and then after this you will have compaction of that soil, right? So height will reduce, volume of the you have to make sure that soil is not lost. Whatever some soil comes out of the mold remains on the disc, that you can transfer there, and you take the disc thickness separately, straight edge thickness separately, and above the disc you keep the straight edge, and from top of the straight edge to the top of the disc, that height you take, and that height over disc thickness adding and straight edge thickness subtracting gives you the settlement amount. That if you subtract from the initial height of the mold, you get the reduced height. Everything is there in the write-up also. That reduced height and the same diameter gives you the reduced volume. In that reduced volume, you have the same soil weight, right? The ratio gives you the dense density. So dense density, loose density you are having, and from there, you get relative density, but you require the in situ density also, and that in situ density we supply to you. Actually, sometimes that in situ density comes out to be more than the dense density or less than the loose density. But in any case, you'll get a relative density number using the formula that will be there, right? And Pilani, mostly it is between 38 to 70%, as you see, right? So automatically it is a loose failure condition, loose shear failure, because void ratio here is mostly not 0.7 but more than 0.8. So it's a loose as per the Weizsäcker criteria. right? And if it is out of 25 sites, if you're getting one or two less than 38 relative density, it is a punching shear failure. But for that also, now we have a setup load settlement on the Moodle footing we can do, and the load settlement and the linear, you have the variation and deviation from the linear. That point is your point from where you can find out the local shear, like wearing capacity. So that will be all, right? Then we move on to third experiment.